Watch Caterpillar build one of these machines, and you understand heavy industry. Even one tire is a huge project. It uses over 130 rubber layers. Many are laid by hand. Then come 24 pistons, each weighing about 15 kilograms. The final cost is enormous. This is the 3,500 horsepower CAT 797B, one of the biggest mining trucks ever built. The main frame begins as 9 castings. They are welded into one beam, 11 meters long and about 28 tons. To carry that load, workers at Amite Foundry in Louisiana start with heavy steel and iron. The charge enters a giant electric furnace. 3 electrodes create the arc. Heat rises past 2,200 degrees. The metal starts to melt. After about 2.5 hours, the furnace is full of liquid metal. A 9-ton ladle moves under the furnace. The fresh molten iron is about 1,650 degrees Celsius, but impurities remain. Aluminum and silicon are added to remove oxygen. They also drive out harmful gases. Without this step, the casting could trap tiny air pockets. Weakening it inside, the metal fills the mold, then it cools for about 36 hours. When it comes out, the surface is rough. Next comes a demanding job, grinding. For these workers, it is daily life. After grinding the 9 sections, go to Decatur, Illinois for cutting, machining, and welding. Every major weld on the 797 must be prepared with care. Some need many passes. These parts weigh from 200 kilograms to more than 5 tons each. Before welding, each piece is clamped tight. Extra fixtures stay nearby. Once aligned, a welder may spend hours on one area. What stands out is how many critical welds it needs. There are 18 major weld points. Most cannot be done by robots. It takes skill, patience, and control. For decades, Caterpillar has meant yellow, iron. Few brands make this much heavy equipment. The company offers over 200 machine types. Its roots trace back to California. Inventors were replacing horse-drawn plows with steam tractors. From there, Caterpillar grew from tractors into a global heavy industry giant. This 27-ton beam is built to work for over 20 years. To prove it can survive, workers use ultrasonic testing. That is close to medical ultrasound. Even the gel looks familiar. The tool sends sound waves through the gel. Signals become images on the screen. The image shows hidden cracks. A solid blue reading means a good weld. It can take 3 hours to inspect the structure. Every weld is checked. After inspection, the metal gets a thick coating. This is not regular paint. It is a tough protective layer. It shields the frame for years. The CAT 797B also needs giant tires. Each stands over 4 meters tall. Each weighs about 5 tons. That is taller than many small buildings. They are also very expensive. One tire can cost tens of thousands. A full truck needs at least 6. In South Carolina, Michelin builds these mining tires. The company is a leader in heavy-duty tires. Before building starts, raw rubber runs through special machines. That makes it easier to shape. Then it becomes long strips. What makes it remarkable is that much of the tire is hand-built with machine help. Infrared lines guide both sides. They help place each layer at this scale. One small error can ruin the tire. Each 797B tire uses 130 plus layers. Steel reinforcement adds strength. Then the tire goes into a mold to cure. About 12 hours later, the result is ready. A 5-ton mining tire. One tire can cost about 50,000 euros. That is a serious cost. A full set can rival a small house. Without them, the truck cannot move a load. Next comes the engine. This 19-ton power plant sits beneath the Caterpillar chassis. To see how it is built, we go to Lafayette, Indiana. Few factory jobs are as impressive as building a 3,500 horsepower engine. That is supercar power many times over. It has 24 cylinders. Every part is oversized in many ways. It is like 2 huge engines in one, like Any diesel, pistons push rods inside the cylinders. Air is compressed hard. Heat rises fast. Fuel is injected and ignites. The pistons drive down. The crankshaft turns. Power then moves through gears to the wheels. Even the rods show the scale. Each is far larger than one from a normal engine. The factory finishes them with precision machining. Next comes the crankshaft. It weighs about 500 kilograms, yet it spins nearly 2,000 times a minute, so every surface must be ground precisely. How do workers install parts? Heavier than car engines. First, the rod bearings are lubricated. Then parts enter an electric fixture. Hydraulics guide them into place. This reduces strain and improves accuracy. Next, both cylinder heads are aligned. Technology supports every step, even the bolts. Need a special torque machine. They use the No. 9 spindle. It is positioned over the engine. Once the bolts line up, the machine takes over. Several wrenches tighten together. Finally, the finished engine ships to Decatur, Illinois. There, the engine meets the chassis. The bigger the machine, the harder the assembly. Clearance may be only 10 centimeters. Workers avoid hoses and lines while matching the bolt holes. Sometimes they crawl, kneel, or lie down to see the fit. After careful adjustment, the 19-ton engine drops into final position. The 797B cab is also critical. It is built for long mining shifts. Every control and surface is designed for the operator. A complete cab takes about 40 hours to build. There's no simple line here. Small teams build it by section. The truck bed is almost 10 meters long. It is made from heavy steel plate. It carries massive loads. In Fort McMurray, Canada, one huge bed can be made each day. Floor plates and side panels are pre-built. Cranes and cables do constant work. Once lifted, heavy sections are hard to control. Some pieces weigh about 15 tons. Workers use large alignment bolts to pull sections into place. The bolts run in rows along the frame. They are tightened from outside inward. The front wall is one of the last pieces. It is not set straight up. It sits at a downward angle. Because of that, chain hoists are essential. They pull the panel into place. The final job is welding the seams to meet 797B strength standards. Welders may spend 7 to 10 days reinforcing every joint. Building a 797 is never simple. Inside the factory, it takes a dedicated team working around the clock, 7 days a week for nearly 20 days. That is for one 797 dump truck. These 3 workers are on day shift. 4 more take over at night. By now, the axle and engine are installed. Most cab work is finished too. Now the build enters the final stage. But one tough job is still ahead. Installing the transmission. It weighs about 6,300 kilograms. It is lifted by sling and guided into a space barely larger than itself. At this size, one wrong move can damage nearby parts. At the same time, technician Tom installs the tires. Each tire is over 4 meters tall. Each weighs about 5 tons. It must line up with the axle. A normal car uses 5 or 6 lug nuts, but the 797 wheel hub uses 47 lug nuts. That needs a strong pneumatic wrench. Even this tool takes skill. Hold it too far out, and it is hard to control. Keep it close, and the strain is easier to manage. Next comes the 45-ton truck body, shackles attached to both sides. The operator uses 2 remotes to guide the whole lift himself. For an expert, one-person control can be easier. Every lift and level change is in his hands. Rear pivot pins are driven in next. They connect the bed to the main frame. They form the hinge point. for raising and lowering the body. The front mounts are different. Look closely, and you can see two huge hydraulic
cylinders.
They provide the lifting power. At last, the Caterpillar 797 is ready to work. Building this truck takes several factories and over 200 tons of material. Dozens of teams may spend over 80 days. But a machine this large is not built for speed. The 797 spends most of its life hauling up to 400 tons, and it does it at about 40 miles per hour.